So today is where we're going to talk about exponential functions and specifically exponential growth. Go ahead and set up your notes. Exponential functions, Unit 4A, Homework 4 with the appropriate date in the upper hand corner. Title your notes and then set up for questions and comments on the right-hand side of your paper. Go ahead and do that now before beginning. So the National Association of Realtors estimates that, on average, the price of a house doubles every 10 years. Now, Tony's grandparents bought a house in 1960 for only $10,000. Assume that trend identified by the National Association of Realtors applies to Tony's grandparents' house. What was the value of Tony's grandparents' house in 1970 and 1980? So if we know it's going to double every 10 years, we're going to take $10,000, and from 1960 to 1970 is 10 years, so that price will double to $20,000. Now, from 1970 to 1980 is another 10 years. So now we're at $20,000. We're going to double it to get to 1980. And that gives us in 1980 the house would be worth $40,000. Now, the first thing we want to do is we want to compute the difference in value from 1960 to 1970. So in 1960 it was $10,000. 1970 it was $20,000. The difference would be $10,000. Now our next step is to compute the ratio of the 1970 value to the 1960 value. So basically we take the ratio of the 1970 value, $20,000, and compare it to the 1960 value of $10,000. So $20,000 compared to $10,000 gives me a ratio of 2. So take a moment, pause, copy, before continuing on, and I'm going to show you what all these ratios and differences mean. So we want to complete a table of values for the year 1960 to the year 2010. Here I've got it set up. I've got my years going by decades. And then here I'm going to set up this value is decades since 1960. So at 1960 would be a 0, 1970 would be 1 decade, 1980 2 decades, and so on. Now we know the house value started at $10,000, and once again we want to go ahead and fill in the values as we go. We already know that in 1970 it will be $20,000, and we've already computed the difference between $10,000 and $20,000 as $10,000. And then we've also known that the ratio of values, so the ratio of $20,000 to $10,000 would be 2. Now we did 1980, which would be $40,000. When we do the difference of values, the difference between $20,000 and $40,000 would be $20,000. Now already I notice this is not going to be a constant value. With linear, we've noticed that if it was linear, we would have the difference of $10,000 every single time. But since we notice it's different, we know this is not going to be a linear function. And so now I want to do the ratio. The ratio of $40,000 compared to $20,000. And I do find that my ratio is the same, which is interesting. So we want to go ahead and fill in the other values, once again following the same pattern of it doubling every year. And then find our difference values by comparing the difference between each set of years. And then find the ratio by taking the year below and dividing it by the year above it. So take a moment. What patterns do you recognize in this table? You can include the ones we've just talked about. Go ahead and be as detailed as possible. We will discuss your answers in class during small group. Go ahead and take a moment, pause, copy everything on this page, including the table and all the data in it. So using the data from the table on the previous page, I went ahead and graphed the ordered pairs. And once again, decades since 1960, that's why these go in ones. They represent each decade since 1960. So you notice that I went ahead and graphed these, and if I draw a line on my values, connect the dots, so to speak, you're going to notice this is definitely not linear. It has a decided curve to it. Now we can talk about domain and range with regards to this graph. I just know my time has got to be greater than 0 because we can't have negative time. And I know that the value of the house, the f of time, the function of time, has just got to be greater than $10,000. That was the starting value of the house. So using the information that you have regarding the house value, what I'd like you to do is use the graph in the table to predict the value of the house in the year 2020. Explain to me how you came by your decision or your answer. We will discuss your answers in class during small group. Go ahead and take a moment, pause, copy everything on this page before continuing on. So the increase in house value for Tony's grandparents' house is an example of an exponential growth. It can be modeled using an exponential function. So here I have f of x equals a times b to the x power. A is considered your constant factor, and we can always think of it as the initial value. B is going to be your growth rate, the rate at which it's growing. And keep in mind, in order for it to be growth, the growth has to be greater than 1. So the value of B has to be greater than 1 to be considered. So if I look back at the example with Tony's house, I can talk about my initial value being 10,000, and I can talk about my growth rate being 2, the constant factor at which it's multiplying. So I would have f of x equals 10,000 times 2 to the x power. You can try that out with your table and see if it comes up with the values you've known. So I'd like you to try this out. Here's another example for you. I've given you the function, and I want you to go ahead and create a table of values, create a graph, and then answer a couple of questions about what you notice in that. Once again, the try it out we'll talk about in class when you come to class next. The next page will have the answers so you can check your work and make sure that you come with any questions. Take a moment, pause, copy before continuing on to the answers. So here are the answers for 1 through 5. Once again, any questions you have, please make sure you ask them during the first 15 minutes of class when we're going over this. Good luck, and I'll see you next class.